Okay, now we're going to
go over operations,
convert a polar equation to
the
rectangular.
power rules.
So remember, if we
got
can
something
get
like this. All right, and I'll touch on the other things too.
something
so remember,
to be our cosine, that converts
the
to
radius
x,
to the fifth power,
and our sine,
then the thetas follow the laws of exponents.
that converts to y.
So remember, if you have x squared
this cotangent and cosecant, first thing we're going to do is we're going to convert cotangent to cosine over sine,
it'll be cosine,
and cosecant to 1 over
in this
sine.
case,
well,
5 times the
times
theta,
sine is sine squared. So to separate the cosine over the sine squared, we're going to multiply both sides by sine squared, which is what we did right there. Now look at what we have. We have sine squared times r. So if I multiply, all I did here was rearrange and wrote it as r times sine squared.
That's how that works.
If we multiply both sides by r,
as it applies to an actual
I now have 3
look at what we have.
Cosine.
We have
21. Our cosine converts
root 21
to x. And r squared
to the
sine
fifth.
Squared
well, that
is
means
the same
root 21
as r sine theta
times root 21
times r
root
sine
21.
theta.
I got tired of hearing
r squared sine squared.
Then
r sine is y times y
5 times
y squared.
3 pi halves.
So now you have y squared is equal to 3x. Since the y is squared, that means we want to get the x by itself. So divide both sides by 3, and then I'm just going to flop the sides.
Well, root 21 times root 21 is 21.
Y squared.
This root
over 3,
21
but that's difficult to read backwards.
And
then
now we have our left
this graph right here,
21. Well, 21 times 21
on a
is
polar graph
441 times root 21, and then
they would look the same
inside the parentheses,
right?
5 times this one 3 pi halves.
So
is
if
15
this
pi
was cotangent cosecant, and that equaled x equals y squared, if you've got tan secant, it's going to end up y
just
equaling
like that.
x squared.
All right.
So notice the difference.
When you're up here and you multiply,
an up or down parabola is when it's
one,
tangent secant.
So
and when it's a sideways parabola,
R1
it will
times
be
R2
cotangent cosecant.
and then
Those
inside,
in there. I didn't write them,
again, the thetas
here.
follow the laws of exponents.
Thetas.
When you multiply powers of the same base,
we converted
you
the
add
sine
the exponents.
over
So when we multiply
cosine, secant to 1 over cosine.
Polar
cosine times cosine is cosine squared.
Polar rectangular.
You multiplied both
polar
sides by
form
cosine squared.
Complex
then I
numbers.
Multiplied both
You add
sides
the
by
thetas.
r.
So in this case, it would be
r
330
sine converts
degrees
to y. R squared
plus 60 degrees.
cosine squared.
And that's the work I would want to see.
Means the same thing as
except
this.
for not writing
r
it
cosine,
down wrong.
which is x.
I don't want to see that.
Another r cosine equals x, so that's x squared.
All right,
I divided
so in this
both sides
case,
by 4.
2 times 6 is 12.
And then just rewrote it the way our brains like to see
330
it.
plus 60
y
is
is equal
390.
to x squared over 4. So that is just a wider upward facing parabola. So if this would have been on a polar graph,
just like that. Now, the one that I meant to show you, I didn't mean to do this one. You guys know how to do these. You just multiply by the conjugate and then simplify.
So if you put that into Desmos,
so we're not going
to
mess with this one.
Okay,
but so let's pretend for a second.
Well, now
over
you've got
here,
a plus
we would have had
subtract.
2.
So this is going to be a little bit dicey here.
Cosine 330 plus I sine.
First thing I did is I grouped this by putting in parentheses.
And that was divided by
multiplied by
6.
both sides, because r squared I can
Cosine
immediately
60
convert to x squared
plus
y squared.
Degrees.
Well, since I'm multiplying this side by r,
you divide. 2 divides 6 simplifies to 1/3.
R cosine,
and then remember laws of exponents,
converts to
x to the fifth.
R sine converts
x squared
to y. So
you subtract
2x,
the exponents.
2y.
So when you divide,
since this is x squared
theta
plus
1
y
subtracts
squared,
theta 2.
we want to get
so inside here it would
the
be
x's
cosine.
and the y's over to the other
subtract
side. So we subtracted 2x,
270.
subtracted 2y. So this zeroes out on this side. And when I subtract it, I'm going to put the subtract 2x.
And then we're going to come down
next
here
to x squared,
and do the
and then I'm going to put a plus blank.
So
you need to establish
both
your
of
case.
these,
we're going to complete the square.
And you just count until you
and
have
then
4
y
of them.
squared.
You start at 0.
I put the subtract 2y next to the y squared.
Notice it'll always be
plus
1
blank
less than
equals 0 plus blank plus blank.
root.
When I complete the square,
and
remember
establish
the c
your
is
first
equal
theta, and remember how you get your
to b divided by 2
it
squared.
is
Well, negative 2 divided by 2
theta divided by
1
divided by
negative
n.
1 squared is 1. So we added the 1 here. We added
And
the 1
technically,
here.
it's
But we also
here.
have to add the 1 to
I
both
didn't leave
sides.
enough
1
room.
plus 1 is 2.
But
And now look at
it's
what you
also
have. You have
plus
x
the 2
minus
pi
1
k
squared
divided by
plus
n.
y minus
But
1
the
squared
first one is
equal
when
to
k
2.
is 0.
So that's
So
a
when
circle
k is 0, this
with
part just
center
cancels. So we're
1,
going to take
1.
our theta, our given theta.
I don't know how to get rid of that, but okay, there we go.
We're going to divide that by the n. So then I'm going to multiply by the reciprocal.
On this one, it's pretty.
So that's 5 pi 16ths. So our first theta,
okay, for this
when
one,
k is 0,
all we have is a negative
is 5 pi 16ths.
For our
so
sign.
now we have to find the pattern.
So if I multiply
So
both
to find
sides
the pattern,
by r, well then I have r squared equals
you
negative
take
4
the 2
r
pi
sine,
k
that
when
converts
k
to
is
y,
1 and divide
and
that
r squared
by
converts
n.
to x squared plus y squared. So now
Well,
all we're
2
going to
divide
do
4,
is
that
add
simplifies
4y
2
to
pi
both
halves.
sides.
So
the
each
x squared, we
successive
don't have to complete.
angle, we're
That's
going
just
to
going to
be
be
adding
x squared.
pi
And
halves,
then to
which by the way is the same
square,
as
when you have a 4y,
8 pi 16.
half of 4 is 2.
So,
2 squared
we're going to
is
take the
4.
4th root of 3.
So then we add 4 to both sides.
Our first
and then
theta is 5 pi
this
16ths.
completed square. Oh, I forgot to say that over here. Once you have a completed square, it factors to binomial squared. And then you know what shape you have. You have a circle. And then right here, same. This right here,
And
this
comma and
simplifies to a binomial
square.
squared.
K is equal to 0.
And again, we still
Right.
have a circle, but this time the
And
x
to
coordinate
all
of the center of the
next
circle
three,
will just be 0.
we're
'cause there's
adding
not a
pi
parentheses.
halves
And then
or
the opposite
8
of
pi
positive 2 is
16ths.
negative 2. And then
That's
the
supposed to be
radius, the
16
square root
right
of
there.
4 is
So
2.
8 plus 16.
All right, let's see if
8
there's
plus
a different type.
8 plus 5 is 13, so
Yeah,
13
well,
pi 16ths.
Okay, these are the ones that get a little bit dicey. When you see a theta equal, just know you use tangent as an operator. You take tangent
8
of both
plus
sides.
13 is
And then
21.
remember, this is just a fact you're going to have to memorize at all of the
and then
pi
by
sixes.
the way, if the thetas can simplify, you do
pi
have
6,
to simplify
5 pi
them,
6, 7 pi 6, 11
in
pi
case you
6.
run across one. In this
then
situation,
all of the pi
I don't think
thirds.
we're going to run across one that simplifies.
At all the pi
But
6's, tangent
you
will
need to
either be
make sure that
positive
you do
or
simplify
negative
them.
root 3 over
And then
3.
for our last
At
one,
all of the pi
21
thirds,
plus 8
tangent
is
will
29.
be positive or negative root 3. This is 150, which is 5 pi 6. So 1/2 divided by negative
how
root 3
smooth
over
and
2
easy that is
simplifies
if
to this. In the second quadrant, tangent is negative. Remember,
0, 1, 2,
tangent
3.
is positive
If
in
ahead
third,
of time
and all trig are
establish
positive in the first.
the
So
first
the second,
theta when k is
tangent is
0,
going to be negative root 3
and
over 2.
then you establish
All right.
the pattern.
So now we're going to
And
convert tangent
write
to
the
sine
pattern
over cosine.
with the same
And then to
denominator
separate the sine and cosine,
as the theta.
we're going to
So
multiply
then that way it's
both
just
sides
really
by
easy.
cosine.
5
And then we're
plus
going
8,
to multiply both
13
sides
plus 8,
by r.
21 plus 8.
Because remember, the whole point
pretty
is
smooth.
to get it
All
back
right,
to x and
that's
y.
it.
So r sine, we can now convert to y. And then negative root 3 over 2, r cosine can be converted to x. And now you just have this negative line, whose slope is negative root 3 over 3. All right, I think I'm going to show you the steps on this one. So a little bit dicier because that's a double angle. So I wrote this as 1 over 2 theta, which is, and I converted the one that I chose, remember cosine 2 theta, the double angle, has three options. Cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 cosine squared. So I chose that because it's easy to separate the cosine and the sine. I divided both sides by r squared. And then I multiplied. I did the distributive, r squared times cosine squared, r squared times sine squared. And now look at, I now have r squared times cosine squared converts to x squared, subtract, r squared sine squared converts to y squared, and I'm going to put this invisible 1 over here. Now that we have a fraction equal to a fraction, I can flip both sides. And now I just have 1 is equal to x squared minus y squared over the invisible 1. That's just a hyperbola whose center, because there's nothing in the parentheses with the x and y, whose center is 0, 0, and to graph it, to sketch it, you go over the square root of 1 is 1, and you go up. The square root of 1 is 1, and then you draw that invisible square, and then you draw the diagonals through the square. And because the x is positive, for hyperbola, when the x is positive, the graph opens to the left and right towards the x-axis. If it would have been y squared minus x squared, it would open towards the y-axis. All right, that is it for the different polar to rectangular equations.